This is a continuation of section 2, and you should be on the top of page 6 of your packet. We got a couple of more examples to go through. This is asking us if you have a box, an open box of maximum volume is to be made from a square piece of material, 24 centimeters on a side, by cutting equal squares from the corners and turning up the sides. So you make a box, the original piece is 24 centimeters by 24 centimeters. Part A, if V is the function of x, write the function and determine its domain. And part B, what length x should be used to maximize the volume? All right, so let's go ahead and draw out some information. Here I've got a box. And it's 24 by 24. So if I cut off these square corners, and I don't know what the measurement's going to be, then we can label these dimensions as x. Each of them are x by x. So if that's the case, then if this whole segment's 24, then the actual length of the box in here would be 24 minus 2x. So here's what we've got. After folding up the corners, it says we've got this open box. This is 24 minus 2x. The other side would also be 24 minus 2x. And then the height is x. So there's my box here. We want to see what the volume of it, how much can we fill in the inside. Volume is found by taking V equals length times width times height. So here's what I've got. Volume equals my length and my width are the same, so it's 24 minus 2x squared, and then times my height, which is x. This is the equation that we'll use for representing the volume. Now, the first question is, what is the domain for this expression? What is the domain? What are the x values? Well, let's think about this. What kind of x's can I put in here? You know, what kind of measurements could I have to cut off the corner? What's the length? Well, you can't cut off a measurement of 0. You could cut off a ½ an inch. You could cut off an inch. So we know that the domain is going to start and be at least greater than 0. That corner that you cut off to fold up the edges has to be greater than 0. What's the largest number, or what can it not be? Okay, well, let's think about the expression here. What would cause this, if you cut off the edges on both sides, to be 0? 24 minus 2x. If your length that you had for the box would be 0, which means you wouldn't be able to have a box. Okay, that's 24 equals 2x. So x would equal 12. So just logically thinking about this, as long as your measurement is anywhere between 0 and 12, not including those, you could create this rectangular prism. All right, the next thing that we're going to do is, so this is your domain. The next thing we're going to do is that second part. Let's go back to the question. The question said, what length x should be used to maximize the volume? Well, if I want to maximize this volume here, then what I'm going to do is take the 24 minus 2x squared times x, times the x, and I'm going to build a table of values. I know my x's are only between 0 and 12, and the y then is the result of the volume. So let's say we don't want to put 0 in here because we know what the result's going to be. It's going to give us a volume of 0. All right, if I go ahead and, well, let's say I cut off 1. We're going to just use integers. So what you do is you put 1 in. So 24 minus 2 squared times 1. So basically, when you calculate this, you get 484. Okay, now let's say it's 2. What if my result's 2? So you do 24 minus 2 times 2, which is 4, squared times 2. You calculate this, and you get 800. You can see my volume's going up. If it's 3, you do 24 minus 2 times 3, which is 6, squared times 3, and you get 972 after calculating that. Let's try 4. You do 24 minus 2 times 4, that's 8. You square it, and then you multiply it by 4. So I'm just substituting these x values, the input-output. You get 1024 for a volume. And let's try 5. 24 minus 5 squared times 5. When you substitute that in and you simplify for 5, you get 980. So you can obviously see here that I've maximized my volume when the length is 4. So the answer to that, here was my equation, V equals 24 minus 2x squared times x. Domain was between 0 to 12, but not including them. And then 4 centimeters was maximizing the volume. All right, let's go ahead and look at the next example. Example 10, a right triangle is formed in the first quadrant by x and y axes and aligned through the point 2, 1. Write the area A of the triangle as a function of x. So here's what we do know. Area is found by taking 1/2 the base times the height. 1/2 base times height. Well, what's the length of my base? We don't know anything about this point here. We don't know where it intersects, but we do know it's the x-intercept, which is x comma 0. And the same for the y. We know the y-intercept is 0y. So I'm trying to simplify and put information in here. So A would equal 1/2. The length of the base is x units. X, that point is over x0, then the length of the base is x. And my height here would be, you're going up y units, so it's y. Here's the problem that we have. They want us to write a function a and have it in terms of x. Right now my function's in terms of x and y. So in order for me to do this, I need to try to figure out how I can write x and y so that I have an equation where I can replace the y with x's. The only other thing that we know about this whole problem here is we got a point 2, 1. We've got a line that's cutting through the axis. Okay, the only thing that we can determine and figure out is where you put x's and y's together is your slope. Let's find the slope of this line, and let's find the slope between the 2, 1 and x0 and see what we get. So slope between 2, 1 and x0. So you do y minus 0, 1 minus 0 over 2 minus x. So this is 1 over 2 minus x. That's the slope. Okay. We have to get the y involved. Well, we can also find the slope between the y and the 2, 1. So another slope, if you have the slope of the line, it's going to stay the same throughout the whole problem. So you have y minus 1 over 0 minus 2. So I just did rise to run. You get y minus 1 over negative 2. Now what we know about both of these is that they're both the slope. That means they're equal to each other. Okay, so what I'm going to do is I'm going to take 1 over 2 minus x, and I'm going to set it equal to y minus 1 over 2, since they're equivalent to each other. We're just going to try to solve this for y. If I solve it for y, then I can replace the y. Cross multiply, or I'm just going to actually just multiply the 2 over. 2 over 2 minus x just multiply the 2 across. This is now equal to y minus 1. I need to add the 1 over, so 2 over 2 minus x plus 1 equals y. I don't want to substitute this in though because it's an expression. So let's find common denominator. 2 over 2 minus x plus 2 minus x over 2 minus x. Combine all these together, you get 2 plus 2, so it's 4 minus x over 2 minus x. And let's go back here. In my slope here, my y minus 1, it was a negative 2. So I multiplied the negative 2 across. We're just going to make some adjustments here. Okay, so this is negative 2. This is negative 2. And now negative 2 plus 2, that's 0. So I just have negative x over 2 minus x. All right, that's what I'm going to substitute. So here's my final expression. Y equals 1/2 x times negative x over 2 minus x. Okay, let's go ahead and simplify this into a better expression. Area equals, you've got 1/2 times x times negative x. It's negative x squared over, the 2 can be multiplied on the bottom here, 2 times 2 minus x. That would represent how to find the area of that triangle there in that first quadrant. Now, to determine the domain of this, my domain is going to be, again, my x values. Looking at my problem, my polynomial, or my expression here, not my polynomial, but my expression, x can be any positive number because this is the distance right here. It can be any positive number here. The only issue is that we can't divide by 0, so what will make the denominator go to 0? Okay, that would give us a 2, a value of 2, and so my domain is 2 to infinity. And the reason why I know that it has to be that is because this ordered pair is at 2, and my triangle is to the right of that, so we can't be left of 2. So 2 to infinity, that's your domain. All right, let's go ahead and look at, the last thing that we're going to do is what's called the difference quotient. The difference quotient is something that you're going to use later on when we start doing limits and into calculus. A little bit of experience here today because of the way it kind of shows evaluating functions. All right, if I want to find the difference quotient, here's what we need to do. You're going to do f of x plus h. That means put x plus h in for the x. And then we're going to subtract the function at x, and then we'll divide by h. So here's what it would look like. First, we're putting x plus h in. X plus h squared minus 4 times x plus h plus 7. Okay, all of that right there, that is just this first portion. Okay, now I need to subtract the function, minus the function, and I use parentheses because of the signs, all over h. Okay, we're going to FOIL the first, so when I FOIL that, you get x squared plus xh twice would be 2xh plus h squared. Distribute the 4, minus 4x minus 4h. We've got the plus 7. Distribute the negative, so negative x squared plus 4x and minus 7. This is all over h. Now we can start canceling some parts out. I've got minus 4x here, plus 4x. They are opposites. I've got plus 7 and minus 7. I also have negative x squared and a positive x squared. And it looks like that's all I have for like terms. So here's what I've got left. I've got 2xh plus h squared minus 4h. And all of this is being divided by h. You can see here that there's a like factor of h. Let's factor it out. You got 2x plus h minus 4 divided by h. The only way that we can simplify this and actually divide by h is as long as h is not equal 0. So we're going to cross those h's out. Here's our final result, 2x plus h minus 4, as long as, since we did divide by h, as long as h does not equal 0. Okay, so that is an example of the difference quotient. A lot of it is just taking your function here and practicing substituting and evaluating. Let's do one more, and then we'll be done. This time my difference quotient is asking us to put an expression in of 2 plus h and then minus f of 2. So let's go ahead and put 2 plus h in. So we've got 2 plus h squared minus 4 times 2 plus h plus 7 minus, so all of that is just the first expression here. Let's find what is f of 2. What does f of 2 equal? So that's 4 minus 8 plus 7. All right, so when we calculate this, you get negative 4 plus 7, so this is 3. So f of 2 is 3. We're subtracting the result, so minus 3 all over h. Okay, we're going to FOIL this. 4 plus, you got 2h twice, that's 4h, plus h squared, minus 8 minus 4h, and 7 minus 3 plus 4. All right, simplify. This is still all over h, so now let's simplify. Cross out some parts. 4 plus 4 is 8, and then the minus 8, they all go to 0. 4h, negative 4h goes to 0, so we're left with h squared over h. We can divide that and get just h as long as h does not equal 0. Okay, so we have to pay close attention to the domain here. And that is your difference quotient. All right, this concludes the section 2 here, and here's your assignment for this portion.